Recording is okay. The recording started. Now, today we are going to start with the very important point, that is temperature stresses and strains. This is very important point as far as on the examination point of view. So, those who belongs to diploma, that point is covered in their SOM syllabus. They have to help me with the sort of information. Okay. So let us see what is temperature stress, what is temperature strain, how the deformation is done or how the compression is done with the help of variation in the temperatures, and what is exactly the role of variation in the temperatures which affect to the property of the material. Okay, we'll be looking for. Just tell me if there is a metallic body or metallic rod is there. If I increase the temperature of that metallic rod, what will be the effect on that rod? Is does it goes to tension, compression, or it will expand or contract? What will happen? Tell me. If there is a metallic rod, and if I increase the temperature of that rod, or say I will hit that rod, so what will happen? Is it undergoes to the tension, or is it undergoes to the elongation or compression? Am I audible to everybody?
Yes,
Then
sir.
tell me, what will happen if we will hit a metallic body? Does it undergoes to the compression or tension?
Tension,
Okay. So because of tension, does it undergoes to the elongation or compression? Very
elongation.
good. Elongation means its parameter will be increased, its dimension will be increased somewhere because it is subjected to a expansion. Let us see what will happen. Temperature stresses. Most of the material expand when heated and contract when cooled. It is a property of the material. If we heat them, it will be subjected to expansion, that is elongation, and if we cool them, they are subjected to contraction. It is a property of any material. If the expansion of the structural member is constrained means restricted. If the expansion of the structural member is constrained, that is restricted, it will cause the stress to develop, which are known as the thermal stresses. Means what? Means what? If a metallic body is there, if a metallic bar is there, okay, which is free at the both end. Right now, we have seen in the previous lecture, we have seen the three different cases. A bar which is subjected to both end free, one end is free, and both end is fixed. These three cases we have seen, and accordingly, we have solved the numerical based on that by the application of principle of superposition. Similarly, if there is a rod which is free from both ends, and if I hit them, it will expand as it is a property of material. But if that rod is fixed at the bottom, if that rod is fixed at both the end, what will happen? Does it undergoes to the expansion? Does it undergoes to the expansion? Are you getting me? Are you getting my question? Try to understand that slide, theoretical part. Once this theoretical part is clear to you, it is very easy for you to solve the numericals. Okay, so try to understand this theory part and try to be active in the conversation. Are you getting me? First point, what we have seen, because of the increase in the temperature, the material is subjected to expand. Because of the cooling, material will undergo the contraction. If any body which is free from the both end, and if I hit them, what will happen? It is undergoes to the expansion or contraction. What will happen? It under
Contraction.
contraction. The body is free from the both end, and if I apply heat, does it undergoes to the expansion or the contraction?
Expansion.
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 What is the metallic property? Whenever you hit the material, whenever you hit the metal, it undergoes to the expansion. Whenever there is a polymer or plastic, if you hit the polymer or plastic, it undergoes to the contraction. Thermosetting plastic and thermosoftening plastic is again, that is another part. But right now we are talking about the metal. Okay. So this point is clear to everybody. Now again I'm repeating the question. Everybody has to be very active and very interactive. If I have a rod which is free from both the end, we have seen the three different cases of the rod. One is, first case is both end is free, one end is fixed, and both end is fixed. Now I'm talking about first case. When the rod which is free from the both end, and if I hit that rod, what will happen? It undergoes to the expansion or contraction.
expansion,
Very good.
expansion,
Very good. It
Expansion.
undergoes to the expansion. Perfectly correct. Now my second question is, if that same rod, or if any rod, if I put fixed from the both the end, if I fix the both end of any rod, if I put a rod to the fixed end at the both the end, or fixing the both the end, and if I hit that rod, what will happen? Does it undergoes to the expansion?
contraction,
Does it undergoes to the expansion? Or does it undergoes to the expansion? Why contraction? Beta, somebody is saying contraction. Why contraction? I can understand the material is, if the metallic body is heated, it undergoes to the expansion. And if both end are of the same material is fixed at the both end, why it is undergoing to the compression? Are you getting my point? Try to listen my question carefully. Yeah, I'm repeating. A metallic rod is fixed at the both end, and if I hit that rod, does it undergoes to the expansion? Does it undergoes to the expansion? Yes or no? Just tell me yes or no.
No, sir.
No. Okay. In first case, it will expand. In second case, it will not expand. Why?
because of both end are fixed.
Perfectly correct answer. Because both end are fixed. Means that structural member is constrained, or its expansion is restricted. Are you getting my point? Why it is not expansion? Why it is not expanding? Because its both end are constrained or fixed, or the expansion is restricted. If such a case is observed, in that case, it will cause the material to develop stress, and that type of the stress is called as a thermal stress. In first case, there is expansion of the material. In first case, that is the both end are free. In that case, the material will expand, means that condition is said to be a free expansion case. Expansion due to temperature variation. In such a case, there will be no any kind of thermal stresses are induced. The thermal stresses are induced when and only when the free expansion of the bar will be prevented or restricted. Are you getting my point?
Yes, sir.
Please answer my question. What do you mean by free expansion? Try to give the answer. What do you mean by free expansion? What do you mean by free expansion? तुम्हाला फ्री एक्सपेन्शन बद्दल काय समजलं? फ्री एक्सपेन्शन काय असतं? What do you mean by free expansion? Anybody? What is free expansion? Free expansion means only body is free at both ends and it is heated. Because of the heating, it expands. That is called as a
Free expansion,
in that case, thermal stresses are induced or not induced? In that case, thermal stress will induced or not induced? In such a case, thermal stress is induced or not induced? Yes or no? In such a, when there is a free expansion, thermal stresses are not induced. When the free expansion is there, in that case, the thermal stresses are not induced. Am I audible? Am I audible?
Yes, sir.
Yes,
Okay.
sir.
When there is a free expansion, thermal stresses are induced or not induced?
Not induced.
Not induced. When thermal stresses are induced, when thermal stresses are
When
induced,
there are six and
when the free expansion is prevented. When there is a free expansion due to the temperature difference is prevented, in that case the thermal stresses are induced. Everybody getting my point?
Yes, sir.
Okay.
yes, sir.
When there is a free expansion, thermal stresses are not induced. When there is a thermal stress is prevented by external means, or the free expansion is restricted or free expansion is constrained, in that case the thermal stresses are said to be induced or produced. Okay. Now consider a bar of length L. If the temperature of the bar is increased by delta T is temperature difference. Say initial temperature is T1, final temperature is T2. Then delta T will be the higher temperature minus lower temperature will be the temperature difference. Okay. The change in the length of delta L or delta L of T. Delta L of T means delta L is a change in length due to the temperature difference. Okay. Is observed to be proportional to the delta T, means change in the length of the material is proportional to the temperature difference, and change in the length is proportional to its length. Change in the length is proportional to the temperature difference and its length. That is delta L of T or delta L is proportional to the its length and temperature difference. So from this and this we can write change in the length, that is delta L or delta L of T, is proportional to the L into alpha T. Delta L is what? Delta L is what? Free expansion. Delta L is what? It is a free expansion. Or sometimes free expansion if body is free at the both end. And if body is fixed from the both end, in that case it is said to be a free expansion prevented by the barrier, or free expansion is restricted. So that is delta L of T is directly proportional to the its length and the temperature difference. We are removing the proportionality constant and putting this alpha. So delta L of T is equals to L alpha into delta T, where alpha is the thermal coefficient of expansion and its unit is per degree Celsius or per Kelvin. Okay. Try to understand this term. Delta L is a free expansion if body is free. If the expansion is prevented by means of external barrier, in that case delta L is said to be a free expansion prevented by means of external barrier or restrictions. And it is said that delta L is proportional to the temperature difference and its length. So delta L of T is directly proportional to its length and temperature. We are removing the proportionality sign and we are putting the thermal coefficient of expansion as a constant. So thermal coefficient of expansion for the different materials are the different. Okay. For every material, thermal coefficient of expansion is different. So delta L is equals to L alpha into delta T is the equation for the free expansion or the expansion prevented by means of external means. So this is a very important formula. Okay. This is delta L. Now, thermal stresses are developed in statistically indeterminate structure where the free expansion and contraction of the member is either prevented or the restricted. Now just I told you when the thermal stresses are induced, the thermal stresses are induced in the structural member when the free expansion or the contraction of the member is either prevented or the restricted. When the free expansion is prevented or restricted, then and then the thermal stresses will be induced and it is calculated as. How does it is calculated? It is calculated as Delta L is equals to, as per the formula, it is L alpha into delta T. How to calculate strain? Strain is equals to this change in length, that is L alpha T divided by L. So LL get cancelled, it remains alpha into delta T. And stress in terms of modulus of velocity is equals to stress upon strain is equals to E. So we can directly write stress is equals to E into alpha into delta T, or we can write E into strain is equals to stress. So 1, 2 and 3, these three formulas are very important for you. I guess this slide is very clear for everybody. If it is clear, then tell me. Let me go to. If this slide is clear to everybody, then please give me a thumbs up. If this slide is clear to everybody, please give me a thumbs up. That is very important. And please mention the formulas for stress, strain, and delta L in the chat box. Am I audible? Okay, great. So I'm audible to everybody. So please give me the formula for, I'm going to give you a formula. Delta L is equals to L into alpha, L alpha into delta T, delta T, delta T. This is the formula for delta L. Okay, so what is the formula for strain? Strain is equals to L alpha T divided by L. So it remains alpha into, it remains only divided by L. So it will be alpha into delta T. Okay, hold a second. No? Strain is equals to alpha into delta T. And what is the formula to calculate? Stress is equals to capital E into strain is equals to capital E into these are the three very important formulas for you. You have to remember that any condition. I guess that slide is clear to everybody. Yeah? Please give me a thumbs up if it is clear. If it is clear, please give me a thumbs up. Waiting for your response. Huh? If it is clear to everybody, please give me the thumbs up. Okay. So many thumbs up are there. It means the formula and the slide is clear for everybody. Now next. Next. Looking for basic numerical, I'm going to take. A rod is fixed at both ends. You have to be very careful while reading the numerical. Fixed at take the value of alpha as 17 into 10 raised to minus 6 and E as a 90 GP. Let us find out thermal stress is not to exceed, that is sigma T is given to us. Calculate the temperature through which, so T, the delta T has to be identified. Can anybody tell me how to calculate delta T as the stress is given to us? What is the these are the three formula that is required to us. What are the things we do have? So this is given to us. L is given to us. E is also given to us. What is to be identified? Delta T is to be identified. Huh? Delta T is to be identified. T is to be identified. Can anybody tell me if we have the different formulas with us? We are having these three formula. So can we identify the delta T? Let us have a look. L, yes, we have. Sigma T. So L we have. Do we have a sigma? Yes, we have a sigma. This is we are having. Sigma we have. L we have. Then tell me. Everything is there in front of you. Hello. Am I audible? Tell me. Tell me fast. Everything is there in front of you, beta. He has given the answer. So stress divided by E alpha means for child only which formula stress divided by okay. Hello, am I audible? Am I audible? Hello, am I audible?
Yes, sir.
Okay, so I guess you come to know how to solve this numerical and please tell me the answer for that numerical. So Sahil is saying so we can use the formula for stress is equal stress upon E alpha is equal to delta T. So please go ahead and find out the value for delta T if you understand this numerical. Please go ahead and solve this numerical. I'm going to give this. You have to pick the value and you have to put this value in the given equation. Tell me the answer. Tell me the answer. When you use this formula, copy, paste. Sigma they have given us. So sigma is equals to T. Copy alpha delta T is to be identified. Therefore, delta T is equals to please tell me the answer, everyone. Sahil? Am I audible? साहिल मेरा आवाज आ रहा है क्या? साहिल, am I audible? No. Give me the answer for delta T so that I will be cross-check with the already present answer with me.
T है तो सर
How much? 50. Let me check the answer. Okay, so 50 Kelvin is the right answer. 50 Kelvin is the right answer. Very good. Everybody has to do. I guess you can understand. Very good. So many answers are there. Tahil, Jagtap, Nilesh Kuwar, Bagulo. Very good. So many people are giving the answers. So try to understand. The numericals are very easy, but the complete session will be revolving around three. We are looking for the more formulas, but these are the very basic formula that you have to remember. Okay. So numerical number next. Numerical number next. A rail of 10-meter length, each are laid on the track in the morning when atmospheric temperature was 12 degrees Celsius. A gap of 3 mm was kept between two consecutive rails. At what maximum temperature the rail will remain stress-free? Second, if the temperature is raised further by 10 degrees Celsius, what will be the magnitude of stress induced in the rail? Take E is equals to 200 GPa, alpha is equals to 12 into 10 raised to minus 6 per degree Celsius. So we have to identify those conditions, those answers. Okay, let us see what they have given us. A rail of 10-meter length. So L is given to us. Let me check. What is happening? L is given to. So what are the things? L is given to me, that is 10 meter, that is 10 into 10 cube mm. Laid on the track, morning, the atmospheric temperature is 12. So T1 is the atmospheric temperature is given to us, that is 12 degrees Celsius. A gap of 3 mm was kept. So delta L, 3 mm gap. It is nothing but gap in between the two rail lines. Delta L is given to us, that is 3 mm actually. That is 3 mm. Was kept between two consecutive rails. At what maximum temperature? Okay. Okay. Take E is equals to, so E is given to us and alpha is given to us. E is given to us 200 GP, that is 200 into 10 raised to 3 MPa, and alpha is equals to 12 into 10 raised to minus 6. Try to understand what we have to identify. This is the given data. At what maximum temperature the rail will remain stress-free? At what maximum temperature the rail will remain stress-free? So it is nothing but it is a rail line and the delta L is given to us. So for first condition, to understand the solution of that numerical, we must know when the stresses is induced. When does the stress will induce? That we have to identify first. So can anybody tell me if delta L is 3 mm, delta L is 3 mm, when the stress will develop and when it is not? Can anybody? क्या आप में से कोई मुझे ये बता सकता है कि स्ट्रेस या फिर थर्मल स्ट्रेस कब इंड्यूस होती है और कब इंड्यूस नहीं होती? जस्ट नाउ आई टोल्ड यू एट द बिगिनिंग ऑफ द सेशन. Can anybody tell me when does thermal stress will induce and when it is not? Please tell me. When does thermal stress will induce and when it is not? Tell me. I have told you that the first slide is very important and that is required for us to solve the numericals. When does thermal stresses are induced and when it is not? अरे कोई नहीं. शीतल जगताप.
Yes, sir.
When does thermal stresses are induced? I'm not talking about that numerical. I'm asking you the general question. Thermal stresses कधी induce होतात आणि कधी होत नाही. Sahil, induce when the fixed support, induce when the fixed support, uninduced when the freely suspended. Sahil, it is like जो आप बोल रहे हो, it is correct, but it should be like when the free expansion is prevented. In that case, the stresses will be induced, and when the free expansion is there, there will be no thermal stresses. Shitala, you have to look for this. When there is a free expansion is prevented. When there is a free expansion induced in the expansion free, then thermal stresses are thermal stress and expansion restrict. चुकीचं बोलला बाबुल तू, उलट बोलला इथे. When expansion is restricted, when the expansion is prevented, the thermal stresses are induced. And when the bar is freely expand, there will be no thermal stresses. Babul, this is reverse, huh? Okay, come to the point, come to the numerical. Now, in that case, at what maximum temperature the rail will remain stress free? Stress free means up to what temperature it will freely expand. जब तक ये फ्री एक्सपांड होगा, थर्मल स्ट्रेसेस नहीं इंड्यूस होगी. थर्मल स्ट्रेसेस इंड्यूस नहीं होगी मतलब ये स्ट्रेस फ्री रहेगा. Clear? So ultimately what they told us, the delta L is given to you, the temperature is given to you, and you have to identify the delta T. Delta T you have to identify, or else for the given condition you have to identify the value of delta L. If the delta L is more than 3, there will be the stresses will be induced. If delta L will be less, the thermal stresses will be not induced, or the material will be remain stress free. Are you getting me? क्या न्यूमेरिकल है? इन शॉर्ट न्यूमेरिकल में क्या दिया है, उन्होंने आपको बोला है कि दो रॉयल के बीच में गैप है 3 mm का. ठीक है, सपोज अगर टेम्परेचर कम हो रहा है या फिर टेम्परेचर बढ़ रहा है और एक्सपेंशन की वजह से या कॉन्ट्रैक्शन की वजह से दोनों रॉयल का गैप फुलफिल होता है, मतलब 3 mm का जो है वो अगर पैक हो जा रहा है, ठीक है, और उसके बाद अगर फिर भी थर्मल एक्सपेंशन की वजह से एक्सपेंशन हो रहा है, तो देयर विल बी रिस्ट्रिक्शन टू द एक्सपेंशन. In that case, there will be induction in the thermal stress. If it is not, then it is called as a free expansion. So up to 3 mm, it will expand freely, and after 3 mm, it will starts. The restriction is acting on the rails, so that there will be induction in the thermal stresses. So we'll be looking for the calculation. Okay. So we'll be looking for the calculation points. I guess this point is clear to everybody. Yeah? Okay. Let's move. Solution. Case 1, rise in the temperature make the rail stress free. So if it is when at what temperature does it make stress free, we have to check, we have to calculate the delta L. Delta L is equals to L into alpha into delta T that we have seen. So L is given to us, alpha is given to us, and delta T we are going to put. Delta L given to us, L we have, alpha we have, where is alpha? Delta T we are going to calculate. So what does that delta T represent? Delta T represent that the amount of the temperature the amount of temperature required to expand the rail up to 3 mm. The amount of the temperature required to raise the temperature required to expand the rail to 3 mm. That we are going to identify. Why we are going to identify the delta T? Delta T indicate that how much amount of the temperature required to fulfill the gap of the rail, that is 3 mm. So delta L, delta T we are going to identify. Now my question is to say, for example, say that delta T will be 20 degrees Celsius. Say for example that delta T will be 20 degrees Celsius. Okay. So my question is, if that delta T will be 20 degrees Celsius, my question is, if delta T is 20 degrees Celsius, due to that delta T, how much elongation of the bar is there? The answer is there in front of you. Because of if delta T is 20 degrees Celsius, how much elongation of the bar is there? Are you getting my question? मेरा क्वेश्चन समझ में आ रहा है आप लोगों को? अगर आपने कैलकुलेट जो किया है डेल्टा टी, फॉर एग्जांपल ये अगर 20 डिग्री सेल्सियस आता है या 20 आता है, तो उसका मतलब क्या होता है? वो कितना एक्सपेंशन करेगा? कितना एक्सपेंशन करेगा? अरे 3 mm का एक्सपेंशन करेगा, यहाँ पे दिया ना। ये फॉर्मूला क्या बोल रहा है? इस फॉर्मूले को समझ लो आप। ये आपको कंफ्यूजन करेगा क्योंकि इसका जवाब हम लोगों को सेकंड टैब में लगने वाला है। ये क्या बोल रहा है? डेल्टा एल 3 mm का इलोंगेशन होने के लिए या एक्सपेंशन होने के लिए हम लोगों को डेल्टा टी इतना टेम्परेचर लगेगा। अगर मेरा डेल्टा टी 20 डिग्री सेल्सियस आता है, इसका मतलब ये होता है कि अगर when and only when the delta T is equals to 20 degrees Celsius, in that case the rail will expand through 3 mm. Okay, so go ahead, calculate the value of delta T and tell me the answer. Go ahead, calculate the value of delta T and tell me the answer. Please go ahead, calculate the delta T and tell me that. 25 is okay, okay, very good. So many answers are there. Okay, very good. Sahil Gangi, okay, very good. Okay, 25. So let me check the answer. 25 degrees Celsius is the right answer. Now, this is the first answer. At what maximum temperature the rail will remain stress free? जब 25 डिग्री सेल्सियस की वजह से 3 mm होगा तो स्ट्रेस फ्री रहेगा. Now, try to understand question. If the temperature is raised further by 10 degrees Celsius, what will be the magnitude of the stress induced in the rail? Okay, क्या बोल रहे हैं? If the temperature is raised further by 10 degrees Celsius, the temperature 10 degree ने वाढवलं, what will be the magnitude of the stress induced in the rail? Now give me the answer. Right now delta T is 25 degree, which is responsible to elongate the bar to 3 mm. Now this is a 25 degrees Celsius. Now I am going to look over here where it is T1 12 degrees Celsius and T2 is equals to 10 degree. If in that 10 degrees Celsius 12 degrees Celsius, if I add 10 degrees Celsius, so the temperature become how much? 12 plus 10 is equals to how much? 22. So when the temperature will be 22, at 22 degrees Celsius, is there thermal stresses is induced on that member rail at 22 degrees Celsius? The temperature stress will induce in that bar or not? At 22 degrees Celsius. Right now your answers are correct, 25. Now my question is, at 20 degrees Celsius or below 25 degrees Celsius temperature, the rail will produce thermal stress or not?
Not.
Why not? Perfectly correct answer. Who has given the answer?
Dhananjay.
Dhananjay. Okay, why not?
Because of both end are not fixed. Na?
Yes, yet both end are not fixed. Minimum temperature requirement is 25 degrees Celsius temperature required to fix the end. After 25 means above 25 degrees Celsius, the end will be closed, and after 25 degrees Celsius, the stresses will start to build in. Very good, Dhananjay. So if the temperature is raised by further 10 degrees Celsius, what will be the magnitude of the stress induced in that? So they told us, identify the magnitude of stress induced in that, means 12 to 10 is equals to T1 is equals to 12, T2 is equals to 10 degrees Celsius. They have given us. Let us check whether the rail will stress free up to the temperature of 25 degrees Celsius. Now, if it is raised by 10 degrees Celsius, T1 is equals to 12 plus identify, this is 12 that is given to us, and 10 degrees Celsius from the condition. 12 plus 10, it is 22 degrees Celsius, which is less than the 25 degrees Celsius. So it means no thermal stress will be induced in that structural member. Got my point? Why this answer? Because minimum temperature requirement is 25 degrees Celsius to close the gap. After 25 degrees Celsius, the bar will be subjected to thermal stresses. Everybody got my point? Understood the numerical? Why thermal stress is not induced? Because in order to induce the thermal stresses, the temperature should be above 25 degrees Celsius. Clear? Eh? Everyone, if the numerical is clear, then give me a thumbs up in the chat box. If the numerical is clear to everybody, please give me a thumbs up in the chat box. If you have doubt query, you may can ask. Very good. So many thumbs up are there, means you're getting what I'm trying to convey you. Very good. And listen, very good. Pushing the chat. Answer Avishka, good. Numerical number next. I'm just going to explain you this numerical. Now it is 12:30, 12:27. So there may be somebody will wait for you at 1. I'm just going to explain this. You have to solve this as a assignment. I will update this into the assignment book. Okay. Your classroom. A steel rod of 10 mm diameter. So D is 10 mm. L is 2 meter long. Is heated through 25 degrees Celsius. Find the new length of the rod if the temperature is raised to 70 degrees Celsius. So this is initial temperature, this is final temperature. The difference between both will be the delta T. That is 75 minus 70 minus 25 will be the temperature difference. That is 45. Find the magnitude and the nature of the forces required to prevent the expansion. Take E is equals to 2 into 10 raised to 5 Newton per mm square, and alpha is equals to this much. So find the magnitude and the nature of the forces required to prevent the expansion. So what are the different forces acting on that? We have to identify. Okay. So let us identify what is given to us, what is to be identified, and then solution. Diameter is given to us, length is given to us, temperature T1 is given to us, T2 is given to us, E is given to us, and alpha is given to us. These are the given things. What is to be identified? They told us to identify the nature of the force. Nature of the force means either it is tensile or the compressive. And they told us to identify the value of P. P is to be identified in its nature. Either it is tensile, compressive, or if it is acting or not acting, we have to do that too. Okay. So let us do for the calculation. Now T1 is given to us, T2 is given to us. Let us calculate the delta T. So solution, for the solution, I'm going to calculate the delta T first. So delta T is equals to T2 minus T1, that is 45 degrees Celsius. Now from that I'm going to calculate the various terms. Okay, so I'm going to calculate L alpha, delta T, stress strain and other things requires to me. So what is the formula to calculate delta L? Delta L is equals to L into alpha into delta T. L we have, alpha we have, and delta T we have. So I'm going to calculate delta L. So do I have? Yes. Delta L is equals to L into alpha into delta T. So please go ahead and calculate the value of delta L. Please go ahead and calculate the value of delta L. Okay, let it be. So delta L we are calculating. Now they are talking about find the magnitude and the direction of the forces. So again we can calculate delta L as PL upon E. Delta L is equals to PL upon E, just like a simple stress strain. So we have a formula for delta L is equals to PL upon E also. So what we are going to equate? We are going to equate this equation with that equation, so that we are putting the value of delta L in that equation and we are calculating the value of P. Let us move onward. Case 1, we have calculated this. Okay. So that is our delta L. So delta L is this due to the temperature difference. Now initially we have some length, that is 2000. So after the heating, the elongation will be 1.08. The total elongation will be 2000 plus 1.08. Okay, so that is new. Now what about the force required to calculate the elongation, that is delta L is equals to PL upon A. So PL upon A, we are putting the value for the different parameters. Delta L, we have calculated PL upon E. P, we have to calculate. Total length after the loading is this much. A area, as we have the diameter, so we have to calculate the area. So how to calculate the area? Let me put over here. We have to calculate the area. We have to calculate the area. It is pi by 4 into d is, how much d is there? D is 10. 10 square. 10 square. Pi by 4 into 10 square. We have to calculate the area. We have to put this and we have to calculate the answer. So I'm going to keep the answer as hidden. What you have to do, you have to calculate the value of P and you have to tell me the answer. I'm going to update that numerical in the Google Classroom. Please solve the assignment timely and upload into the classroom. Thank you. Thank you so much for attending the lecture. I'm going to stop my recording right now. If anybody is willing to talk to